are going to exert pulling forces, or they'll relax in different areas. So because these muscles can only move in one direction, that's why they are antagonistic. They have opposite functions. When one is pulling, the other one is relaxing. It's exactly the same as biceps versus triceps. So if I flex my bicep, the tricep is relaxed. If I flex the tricep, then the bicep is relaxed. It's antagonistic. So inspiration and expiration. Inspiration means you're inhaling, and expiration means you're exhaling. They're opposite movements, so they require different muscles to be doing different things. There are 3 muscles IB needs you to know about. The intercostal muscles. If you work out and you're like, why are my ribs sore? Your bones aren't sore, the muscles in between them are. That's your intercostal muscles. The diaphragm, that's this one right here. It's just underneath your lungs. And then there's the abdominal muscles, which are right here, your abs. You all have them, whether you can see them or not. It makes you feel better. All right. Here are the gist of it. This chart is directly out of your book. It's just one of those things you got to look at it and find a way to make it relevant. Okay, I will do my best for you. So the diaphragm during inspiration, okay, what's happening, you're breathing in, the diaphragm will actually push down. Your lungs are going to push it down and it will flatten. I really should have had that little balloon thing. Shouldn't I? I didn't want to get that. I'll show it to you after our break. So expiration, the diaphragm will push up and force the air out. The rib cage, this is where the intercostal muscles are. During inspiration, they move up and outwards. It fills up. Your belly gets bigger. And then in expiration, it moves downwards and inwards. It actually pushes on your lungs to squeeze the air out. So as far as volume and pressure changes go, during inspiration, like you might guess, when you're inhaling, the volume has to increase in your lungs, and the pressure is actually decreasing. That's probably opposite from what you think. You have to think about Boyle's law. So as the volume increases, it opens it up more. So there's decreased pressure. Expiration, your volume decreases, and you're actually pushing the air out. So when you breathe out, the pressure is forcing the air out because the volume in your lungs are getting smaller. Just like if you press down on a balloon, that's how you get all the air to flush out of it. The same thing is true for your lungs. So here's examples of all of those muscles. The diaphragm contracts. So it will move downwards and push the abdominal wall out. When you are breathing out, the diaphragm will relax and it pushes up and forces the air out. So muscles in the abdominal wall relax, allowing pressure from the diaphragm to push it out. I want you to look at this, right? So if this is the movement of the diaphragm, if the diaphragm is contracting and the abdominal walls are relaxing, what does this make the diaphragm and the ab muscles to each other?
Antagonistic pair.
So that might be a way that you remember this. So they're antagonistic to one another. Let's do this. So if you can remember what's happening with one, you should be able to determine what's happening with the other. When the diaphragm contracts, you're breathing in. When it relaxes, you're breathing out. So you have to tighten your ab muscles to some extent to breathe out, to exhale, to push. Your abs will actually push down on your lungs to help you breathe out. Okay, the intercostal muscles, there's external and internal ones. One's on the outside and one's on the inside. These are also antagonistic to each other. So as one is contracting, the other is relaxing. So these are the ones on your rib cage that are going to be moving your ribs out when you breathe in and pushing them down when you breathe out. So the external intercostal muscles pull out. If they're on the outside, they pull out. And And the internal intercostal muscles are relaxing to let that happen. They are antagonistic. When the external intercostal muscles are doing one thing, the internal ones on the inside that you don't really feel as much, those are relaxing. You look on the flip side of this, when you are breathing out, when you are exhaling, expiration, the external intercostal muscles relax, and the internal ones contract. It pulls the rib cage inwards and it pushes down on your lungs, and you breathe out. This is just tricky to learn all of this. It's a lot of information. Muscles are kind of a pain. My suggestion, learn half of this chart and realize that they're antagonistic. So if you can learn one half of it, you can get the rest of the way. All right. So now we get to some of the pathological stuff with lungs. So this is a good example of nature of science. We're pretty sure smoking causes lung cancer. We're pretty darn sure that there's a really, really strong correlation with it, but we really can't test it experimentally, because to do a proper experiment, it would require us to have a control group and then to have one group that were like, hey, you, chain smoke for a while. Let's see what percentage of you get cancer. You can't really do that, right? You can't do that ethically. So all we can really do is say, yeah, there's a really strong correlation between lung cancer and cigarette smoke. So ethics can hold us back in some ways, but these are human beings, so we just use the correlation instead, which is just based off of doctors talking to patients who have smoked, who have chosen to do that over time, and then they go, oh, you smoked, geez, we're noticing a lot of people that get lung cancer smoke. So all we can really do is just correlate it based off of that data. Remember, correlation does not denote causation. How can you show causation? Repeatable experimental testing. Typically that will have some kind of control group. It's the same reason why, unfortunately, global climate change will never be, the best we can hope for is a correlation, which for some is not good enough. Right? The only way for us to have causation is for us to get another planet that's exactly the same age as Earth, maybe a few of them, and then have them repeatedly go through the exact same thing as Earth, except for maybe no industrial revolution or what have you, and then compare them, right? And so for some things, it's just not reasonable or possible at all for us to be able to do an experiment that would show causation. So with lung cancer, we could do it, it's just not ethical, so we don't. Causes and consequences of lung cancer. Obviously, the one on the left has the lung cancer, or that one actually doesn't have lung cancer. They just smoked for a while. If they do have cancer, you can't send any tumors to mass. So, smoking, passive smoking. So that's the stereotypical secondhand smoke, right? Air pollution, radon gas, asbestos, which they used to use for insulation. When you guys buy houses in a few years, they'll do like an asbestos test. If they go, no, this needs to get out of here. Coughing up blood, chest pain because you're constantly contracting muscles to cough, loss of appetite, weight loss because you're not eating as much, fatigue, you're tired, because why would you be tired? No air. Yeah, you're not getting as much oxygen, so you're not getting as much ATP, you're not respirating as much.
Now you're doing this coffee.
Emphysema is another consequence. So emphysema, I've described this to you guys, it's like trying to breathe through one of those little coffee straws. Like in Balthrop's class, the little black coffee straws. If you just tried to breathe through one of those, that's about what, really bad emphysema feels like. So smoking causes increased phagocytes in the lung tissue. Phagocytes are an immune response because what you're putting in your body if you smoke is a toxin. And these white blood cells kind of overreact. They produce an enzyme called protease. What do you think protease breaks down? Protein. Guess what your lungs are made out of?
Protein.
Protein. Uh-oh.
Oh, that sucks.
So it destroys the protein in your lungs, those alveoli. And so now you have these deep lung pools of air and no surface area to get it into your bloodstream efficiently. So consequences, you have difficulties breathing, the alveoli damage is irreversible at some point. So once you have emphysema, you are stuck with it. You have to feel like you are drowning pretty much your entire life because you just can't get enough air in your body. Low oxygen saturation in the blood, even though you have deep lungfuls of air, it doesn't matter. Yes, sir. No, so that's different. That's typically indicative of people that have had a cancer, like throat cancer. So it won't help. There's really not much that you can do because even if they put it into your throat, and all it's going to do is like bypass the mouth, right? And that's not going to make a difference because the problem is within your lungs. There's just not enough surface area, not enough working alveoli to get oxygen into the body. So let's see.